Greetings. Welcome to our first lesson for Algebra 2, Unit 1, Lesson 1, a review of solving linear equations. My camera does not work. This is brand new, just happened. That's awesome. So you get a lovely gray circle to stare at instead of my face. I don't know. Maybe that's a win-win. You guys decide. So without further ado, let's go ahead into this lesson. So this is a review lesson on solving linear equations, and it's really based on some foundational things that we want to carry with us into Algebra 2. So if it seems like you've covered this before, it's because you have, and that's a good thing. We want to start off with the key idea. What is a solution? Okay, so this is vocabulary. A solution is the value or values of the variable or variables. Okay, so you'll notice we've got some flexibility there. That make the equation or equations, could be plural, true. And if you're taking notes from home, then I want you to write this down. This is one of the key definitions. I don't want you writing down everything because that'll take forever, but definitely want to write down this key idea. A solution is the value or values of the variables that make the equation or equations true. Now, if we're just talking about a linear equation, then we would use the singular of all of that. A solution is the value of the variable that makes the equation true. But what's really great about definitions is that definitions are broad and they apply to more than just the concept that you're studying at a given time. So we could have one equation that has more than one solutions. So in that case, it would be the values of the variable that make the equation true. Or you might actually have more than one equation that has more than one variable, but if you're asked to solve it, you are looking for the solution would be the values of the variables that make the equations true. So when you can really get that solution, that definition of a solution down, it's going to equip you and empower you to answer more questions than what you might have in front of you right at this moment in this lesson. So what does it mean for an equation to be true? Whenever we're covering vocabulary, we want to make sure that there aren't words in the definition that we don't know the meaning of. So if I ever do that to you, you raise your hand and say, what does that word mean? So you might be asking yourself, okay, well, what does it mean for an equation to be true? So examples of true statements in math would be something like 5 is equal to 5. Okay, that is a true statement. 5 is equal to 5. It would work for negative numbers. So say -1 is equal to -1, or for decimals and fractions. Okay, you could even say 0.5 is equal to 1/2. And what it would mean is that the value on the left is indeed equal to the value on the right hand side of the equal sign. Opposite of true is false. So false statements could be something like 5 is equal to -1, or 1/2 is equal to 0. Okay, we would call those false statements. So what we're looking for when we're solving an equation is the value of the variables that when those values are plugged into the equation, we will end up with what's called a true statement. And that is what it means to solve stuff in math. Okay, if you see a problem and the directions say solve, this is what you're being asked to find. So how does this work? So a great way to kind of start off with this is just by asking if particular numbers are solutions to equations. So we have there, is n equal 4 a solution to 3n plus 5 equals 17? So we would know it's a solution if that value, 4, would make the equation true. And so the way we would check to see if it was is we would do 3 times 4. So we would plug in a 4 for the n, plus 5 is equal to 17. And then we need to follow order of operations. So multiplication would come before adding. So we do 3 times 4 is 12. And then 12 plus 5 is 17. And so we get a true statement. And so my answer would be yes. Now, before we move on from this, I want you to notice a couple things about how the work is structured. So I did a direct substitution. So where I had an n before, I replaced the n with a 4. That process is called substitution. Then as I am working top to bottom. I am not going to string this out left to right. It's top to bottom. And in each step, I did one thing. So in the first step, I did 3 times 4, and I replaced that with a 12. Plus sign came down, 5 came down, equal sign came down, 17 came down. In my next step, I did 12 plus 5 and replaced that with a 17. Equal sign comes down, 17 comes down, and that's all I needed to do. I landed at 17 equals 17. When you are doing your algebra work, each step should follow from the step above it. So I should be able to ask you at any point, like, where did the 12 come from? And you would be able to tell me the 12 came from 3 times 4. Where did the 17 come from? Well, the 17 came from 12 plus 5. If at any point in your algebra work, you would not be able to answer that question, that's when we know we have a problem. Okay. Now, do you always do one step per line? No. Sometimes you can do multiple steps per line, but we do want to be judicious, I guess, about how many steps we're willing to do. Next example that we have there is A equals -1 a solution to 3 times A plus 2 equals A minus 3? So in this one, we would plug in the -1 for the A. Sorry about that. That does not look like 3. Let's try that again. 3, and then we'd have -1 plus 2, and then we have the equal sign, and then we'd have -1 minus 3 on the other side. So if you've got more than one of the variable present in the equation, then you would replace it each one. And then you would follow your order of operations. So our order of operations starts with P parentheses. So again, I don't know why I did that. Out of practice. Parentheses, exponents, multiplication, division, go left to right. They have the same rank as do adding and subtracting. So we'll start with our parentheses. And so -1 plus 2 is 1. And this is where you might do more than one step per line. Like you might come over to the other side here and say -1 minus 3 is -4. Or you might put that off to another line. That's where there's some flexibility. And then after this, we would do the multiplication. And so 3 times 1 is 3, and we get 3 is equal to -4. That is a false statement. And so no, A equals -1 is not a solution. And again, I want you to notice every step follows from the line above it. So if you are being asked, where did you get a -4? Well, -4 came from -1 minus 3. Where did we get a 1 from? It came from -1 plus 2. Where did this 3 come from? It came from 3 times 1. Every single step, you should be able to explain where the number came from. Now, we will often use this definition to check our work to see if the number or numbers that we found actually are solutions. So this process is often known as just a check for your work. It's not the actual solution. It's a check. Okay, you're checking to see if the number is a solution. All right. So why is this a key idea to start out in Algebra 2? Why are we backing up to what feels like Algebra 1, maybe even pre-algebra? Well, here's why. Definitions do not change. Okay, now there are some words in math that have more than one definition depending on the branch of math. So there's like an algebra definition, and then there's a probability definition. But the definitions don't change. So this definition will continue to be how we talk about solutions and solving equations throughout the year, whether we're talking about the noun, here's a solution, or the verb, solve, the entire year. This definition works for all types of equations. So we're going to start with linear equations, but we are going to be using this definition all year. I am so talking with my hands here. My hands are waving all around. You guys can't even see it. So here's an example. Is x equal to a solution to 3 to the x power minus 4 equal 5? This type of equation we cover towards the end of Algebra 2. This is called an exponential equation, and heading into Algebra 2, most of you, if not all of you, don't know how to algebraically solve this. But if you know the definition, you can check to see if 2 is a solution. So you would do the exact same thing. You would take the x and replace it with the 2. And then you would follow your order of operations. Well, we don't have parentheses, but we do have an exponent. 3 squared is 9. And then we don't have any multiplication or division, but we do have some subtraction there. 9 minus 4 is 5. And that is true. So yes, x equals 2 is a solution to the equation 3 to the x minus 4 is equal to 5. So knowing the definition gives you the power to answer questions even on concepts that you have not yet been taught. So you don't need to be taught how to solve an exponential equation to answer this particular kind of question. So you just need to know the definition of what a solution is. It's the value of the variable that makes that equation true. So you plug it in and see if it's true. So we will be emphasizing definitions throughout this course because they are powerful tools for understanding math. And I know that vocabulary and definitions often do not sound like they're very interesting, and maybe they are a little bland, but they are definitely powerful. When you understand the vocabulary, when you understand the directions, when you understand how the math principles work, it's going to allow you to take what you know of math and push forward with it and hopefully make you less afraid of problems that are unfamiliar. Okay, so how do we solve linear equations? Well, we could keep guessing and checking numbers. Okay, so we know how to check to see if something is a solution because we know what a solution is. But since there are an infinite number of things that we could guess, this is incredibly inefficient. So you just start guessing. Now, there are times to guess and check. It's not a terrible math strategy. It just can be very inefficient at times. So we develop strategies and leverage patterns to quickly find the numbers that make an equation true because we don't want to keep just guessing and checking all the time. So here are some key ideas when solving linear equations. What we do is we isolate the variable. So isolate the variable by identifying what operations are being done to it. So I look and find my variable. Usually in math class, it's an X, but it could be an N or an A or a P or Q, whatever we're using that day. And you notice what are the operations being done to it. By operations, we mean things like adding, subtracting, multiplying, or dividing. As we move forward in math, we're going to have more operations like taking a square root or a cube root or raising something to a fourth power. Okay, there's going to be other things, but you identify what's being done to the variable, and then we undo what has been done to the variable, generally in reverse order of operations. Now, that gets a little bit muddy where there are some exceptions to it, but I think it's a good place to start. So we undo what's been done. It's kind of like opening up a present. You've got all this, like the present is wrapped and there's a bow on it. And in order to get at the present, you've got to undo the bow. You've got to undo the wrapping. You've got to open the box. You've got to undo some stuff to get at the present. And in our case, the present is the variable. And so we see what has been done to this, and now we're going to undo it. So I'm going to give you an illustration just about the reversing the order of operations and putting on like shoes and socks. So when I do this in class, I might even bring in my toe caps. My toe caps are things that I put on my toes when I am running more than 20 miles because they stop blisters. And so they go like literally right over my toes. And so that would be the first thing I would have to put on. And then over the toe cap, I'm going to put on some socks. And then over the socks, I'm going to put on my shoes. When I go to undo that, I have to go in reverse order. So the shoes are the last thing that I put on. Therefore, they are the first thing that I take off. I cannot take off my socks unless I take off my shoes. first. Then once the shoes are off, now I can take off my socks. And then once my socks are off, I can take off those toe caps, okay? And so the equations work the same way. You've got these things that have been done to the variable, and when you go to undo them, you undo them in the reverse order. So instead of parentheses, exponents, multiplication, division, adding, subtracting, we're generally going to go in the opposite order when we're solving an equation because we're trying to undo the things that have been done. All right, there we go. Okay, so step one, example one, is a step one, a one-step equation. Wow, been a day. It is a Friday at the end of the school year when I am recording this. So one-step equation. So hopefully you can do this in your head, okay? That like x minus 5 equals 10, that you just figure out what number, subtract 5 would give you a 10, okay? But what I want to do with this is just take a close look at how we reason through this and write it as part of our work. So how do we process this algebraically in terms of a strategy instead of just jumping to the answer? So what I would do in terms of strategy is I notice my variable. Okay, well, there's my variable. Here's an x. And I want to notice what is being done to the variable. Well, we are subtracting 5 from the variable. And that little piece of reasoning is going to come in very handy all year when we look at more complicated equations. So I am subtracting 5. So the way you think about this is you ask yourself, how do I undo subtraction? I undo subtraction with addition. They are what are called inverse operations. Now, you do not have to show this. Okay, so the way you undo this is you add 5 to both sides. You are welcome to just say x is equal to 15. And if I come to you and I ask you, hey, where did the minus 5 go? You would say, I added 5 to both sides. Or if I came to you and said, where did the 15 come from? Well, the 15 came from doing 10 plus 5. If you want to show work for that, okay, I am not going to penalize you for showing that work. What a lot of Algebra 1 teachers do, and what I often do because I don't want to lose my students along the way, it's I will write plus 5 plus 5. There are a lot of students that just benefit from seeing that, but I want to be clear that that is not a required element of your work. It is completely okay for you to skip that. You do what's going to work best for you on that particular kind of step, okay? Now, when you go to show this, it is important that you show it correctly. So the reason that we are adding 5 is because negative 5 plus 5 is 0, okay? And that's going to be how we undo the subtraction. This is the equal sign. It means whatever is on the left side is equal to what's on the right side. Therefore, if I add 5 to the left, I must also add 5 to the right in order to keep it balanced. So I'm going to go all kinds of pre-algebra on you right now. If you have your balance and you have x and you got your minus 5 and then you've got your 10, if you go ahead and add 5 to this side, you've got to add 5 to the other side in order to keep the equation balanced. Do not show just a plus 5 on the right side. You're not just adding it to the right side, you're also adding it to the left side. That's why the negative 5 goes away. All right, so I know I got really like 3.5 minutes in depth on a problem that you can do in your head, but there's a reason we want to get at those ideas and how we write them, and we'd rather do it while the problems are easy. All right, so this is a two-step equation here. And we have a couple things to note. So there are 2 operations being performed in the x, I should say on the x. I hate it when I don't catch a typo. On the x, multiplication by -2 and adding of 4. So we go and find our x, okay, and we say, well, what's being done to the x? Well, the x is being multiplied by -2. That is called the coefficient, and that operation is multiplication. That is -2 times x. Okay, I get students every single year in Algebra 2 that are not clear about what that operation is. So if you don't see, even if you don't see a time sign, okay. Now, if it's adding, you have to see a plus sign. If it's subtracting, you have to see a minus sign. But with multiplication, you do not have to write it. And then this is plus 4, so we're adding 4. So 2 operations, multiplication by -2 and an adding of 4. According to our operation, PEMDAS, order of operations, PEMDAS, we first multiply and then we add. So I want you to think of it this way. Think of this as I am putting on my socks and then I'm putting on my shoes. Okay, so we're going to take the x, we multiply the x by -2, putting on the socks, and then we add 4 to the result of that. We do not do x plus 4 and then multiply that by 2. Okay, not the way that's written. Therefore, when we undo the operations, we will undo the adding first, and then we will undo the multiplication. So that thought process, okay, that thought process running through what is being done and what is the order that it's being done is what dictates how we solve it. So to undo adding 4, I subtract 4. And then sometimes people draw a line here. When I first saw the line there, this is actually not how I was taught when I was in school to structure the work. So this is something I've kind of had to learn as a teacher. All right, bring everything down. So we've got -2x, it comes straight down. 4 minus 4 is 0. That's why it goes away. Okay, it does not go away because of magical math, voodoo. That's like just it disappears. 4 minus 4 is 0. Therefore, you don't need to write plus 0. And then on the right side, 8 minus 4 is 4. So we have undone the adding part. Now, I mentioned that this is multiplication. Okay. And so you ask yourself, how do I undo multiplication? Well, I undo multiplication with division. What do I divide by? Well, you ask yourself, what did I multiply by? I multiply by -2, therefore I divide by -2. And I'm recording this video for the early part of the school year. I'm recording it in May, but I realize that for a lot of you that might be watching this is maybe the first video you've watched and you haven't seen a lot of my work. Sometimes my 2s are loopy, like they have the little loop in them, and sometimes they don't, and there is literally no rhyme or reason to it. But for your future reference, if I'm writing the letter Z, the Z will always be crossed. Okay, so when I cross my Z's, like when I write a Z, I'll always cross it. I will not cross my 2s. All right, coming back to our problem. It's like a little sidebar. I cannot find my cursor. There it is. -2 divided by -2 is 1. Any number divided by itself is 1. That's why they cancel out. Again, they do not cancel out because of magical math voodoo. They cancel out because -2 divided by -2 is 1, leaving me with just 1x. And then 4 divided by -2 is -2. Again, I want to really emphasize the structure of the work. The equal sign comes down. You do not have to show me -4, and you do not have to show me divide by -2 on both sides. But if I were to ask you, where did the -2 go? You would need to be able to say, well, I divided by -2. Okay, divided both sides by -2. And that is our strategy for a 2-step equation, and that's what your solution should look like. If you opt not to show the middle steps, like if you opt not to show the work, again, that is totally fine. You can just say -2 is equal to 4, and then x is equal to -2, okay? That would be totally fine to show. Just know that you should be able to explain what it was you did to arrive at those numbers. Okay, while it is possible to undo the multiplication first, this often leads to errors and is discouraged by most teachers. So there is a way that you could start by dividing by -2, but it is extremely error prone. Okay, it's extremely error prone, and so teachers will almost always steer you away from it. And I'm not even going to address it now, although if you've got questions about it, you can ask me in class. So why is this important to know? In Algebra 2, we will explore many different kinds of equations. And while each family has some unique strategies or concepts we will cover, that's why you're taking Algebra 2, to learn the unique strategies and concepts. All equations, all of them, all solutions are built on this key idea. It's built on the idea of I'm going to undo what was done to the variable. And all we really do is just add on some layers. Like, let's look at a new thing we might do to the variable. Like, we could take the log of a variable. Well, how will we undo that? Like, don't worry about that. That's in the spring. The better you understand the concepts for linear equations, the easier it will be to transfer your knowledge to new equations. So it really is worth it for us to go back and just rehash what you've had in Algebra 1 and to emphasize these ideas on some really simple equations so that when we do start to build on it, you've got a better foundation. So this is the last example I'm going to do. This is what's called a multi-step equation. It just means we've gone beyond 1 and 2 steps, and it does have some other Algebra 1 skills that I wanted to make sure that I reviewed with you before just letting you out on your own. So a general strategy for linear equations. This is like just a general order that you can do stuff in. Step 1, simplify each side separately. Now, when I say side, here's what I mean. I mean side of the equal sign. I once had a student say in a problem that had a fraction, she thought I meant each side of the fraction, meaning the numerator and denominator. And I realized I wasn't being quite specific enough when I said that. So you simplify each side separately. What that means is that we're going to take a look at the left-hand side. And we are just going to simplify everything on the left-hand side. We're going to get the left-hand side as nice and simple as possible. And we'll do the same with the right-hand side. In this particular problem, the right-hand side is already simplified. Now, what do we mean specifically when we say simplify? Well, if there is any distribution to do, you are going to do that distribution. And I am building this lesson on the assumption that you do remember it, but we will look at it in this problem in case you don't. Distribution is when you multiply through the parentheses. It is very specifically multiplication over addition or subtraction. And I know that's maybe a weird way for me to say it, but multiplication over the addition or subtraction, it means you're multiplying it through. So we would have -2 times x, which is -2x, and -2 times +4, which is -8. And then watch how I'm going to do this. I'm going to bring down the -3. I'm going to bring down the equal sign, and I'm going to bring down the 4x plus 8. I am not leaving that stuff just like hanging. Okay, everything comes down, so there's this nice order and logic to the way we're solving the problem. After you do any distribution, then you can go ahead and do what we call combining like terms. And I'm going to go into a little bit more detail for you there. By combining, we mean adding or subtracting. Okay, that's specifically what we mean there. And terms are simply things that are added or subtracted. So things that are added or subtracted. So that means looking at the left and looking at the right. If there are things on that side only that I can add or subtract, then I'll go ahead and add and subtract them. So on the left, I do see that I have -8 minus 3. And so -8 minus 3 is -11. And notice I'm bringing down the -2x. I'm bringing down the equal sign. I am bringing down the 4x plus 8. Okay, I am not messing with any of that. I'm not leaving it behind. I'm not trying to do all kinds of work in my head. We're just bringing it down methodically. Once you've got a problem in this form, then your next step is going to be to consolidate or isolate the variable. Consolidate or isolate the variable on one side. So what we mean by that is we've got an x on the left and we also have an x on the right. and we want to be able to get those together. Now, some people like to always put their variables on the left-hand side. Some people like to keep their variables positive. There's two different ways you can do that. I prefer to keep my variables positive. So the way I'm going to move these over is I am going to do plus 2x on both sides. Now, just so we know the reasoning here, negative 2x plus 2x is 0. That's why they cancel out. This negative right here goes with the negative 11, so that is going to stay there. And then over here, I have 4x plus 2x. Make sure that you are writing the x with that. Do not write plus 2 and plus 2, okay? Your like terms mean that you add x's with other x's and constants with other constants. So if you are going to write that step, make sure that you write it clearly. So we have negative 11 equals 6x plus 8. And then our last step down there is just solve the resulting 1 or 2 step equation. So if you follow this strategy, by the time you get to this point, it's just either a 1-step equation or a 2-step equation at that point. And so I will go ahead and finish that by subtracting 8 from both sides. Negative 11 minus 18, or sorry, 8 is negative 19 equals 6x. And then dividing both sides by 6. And that is an awesome fraction, which will often kind of throw students for a loop. I know you guys don't like getting fractions as answers, but leave it as a fraction. Don't feel like you need to change it over to a decimal. A couple of things before we leave this, and then the next thing is going to be some practice work for you. I do want you to really take note of how I have structured this problem. It flows from top to bottom. Every step comes from the step above it, so there's no question like where did we get a negative 19 from negative 11 minus 8. This is going to help me tremendously when I look at your work, and it's going to end up helping you as well, because realistically, at some point in this process, most of us are going to make a mistake. And I include myself in that, where I will add something wrong or multiply something wrong. I'll make something positive that's negative or vice versa. This way of laying out your work is going to make it so much easier to find your mistake and identify whether it's like a careless error or whether there's a conceptual problem or whether we need to back up and kind of engage a different strategy. So if you understand the algebra, but you're constantly messing up, like adding negative numbers, that is helpful to me as your teacher to be able to figure out a way to help you so that you're not letting your arithmetic make your algebra problems wrong. Okay. So if you are taking notes, definitely the example problems, you definitely want to have this down. And I did try to color coded. I kind of messed it up right there where I switched colors from the red over to the purple. But I did try to put the simplification steps in one color, and I didn't do it as well as I maybe have done before, but I think you get the idea. All right, so that brings us to the practice problems. So these are your practice, complete on a piece of paper to turn in. Is how we'll do it in class. Generally speaking, if you're absent, and I'll excuse you from stuff that's strictly done in class, but you probably would like to do them anyway. So solve each equation, use the concepts presented in this lesson, even if you can solve them in your head. So the first one, x plus 10 is equal to 8. You might be able to do that in your head. Number 2 does involve a fraction. Okay, so see how that goes, and you can be creative with ways that you might solve that. All right. And now when you get down to number 6, it says check your answer to number 5 only. So don't check your answers for all of them. Okay, that's kind of takes a long time. So we want to be intentional about that. Check your answer to number 5 only by substituting it in and looking for a true statement. So hopefully you'll have an answer for number 5 that you arrived at on your own, and you're going to plug it back in. If your solution was not correct, so you plug your number back in, but you don't get a true statement, I want you to try to find your mistake and rework your problem below where your check is, okay? And that, I'm very interested in your process there, more than whether or not you get the right answer, Okay, like it's about the process and how you're thinking about the problem. If you did get the correct solution, I want you to look at number 5 and write down what you think is a common mistake in this particular problem. And there is a common mistake in this particular problem, which is why I'm asking you to go back and check and see how it goes. So if you're doing this from home, pause the video and give yourself some time to practice what we went over in this lesson. And then for your homework, so we've got a group of problems. The first 4 are going to mirror exactly what we did in the lesson. Question 5 is just a heads up, this one is going to look different. So when you get to the end of that problem, it's not going to do what the other ones do. I just want you to heads up, like that doesn't mean you did anything wrong. So it's going to look different. Once you see what that is, I want you to write down for number 6, what do you think this means for the equation in number 5 when you look at it? Then in numbers 7 through 9, use what you know of solutions to determine if the given number is a solution to the equation. So for 7 through 9, those are all families of equations that we have not at this point gone over how to solve. Now 8 you might have seen in Algebra 1, but probably not 7 and 9. What I want you to do is just tell me, yes, this is a solution, or no, it isn't, using the definition of a solution. And if you want to rewind the video, like I did one that was an exponential this way. And then question 10, of the problems you answered, which ones would you like to review as a class? And do not request to review problems that you skipped. So writing IDK and just asking Miss Taylor to do it is not how we're going to play this. So you're going to try the problem, and then once you've tried the problem and you've got your attempt, if you have a question on it and you would like to review it in class, that you can write down to request a review, but you've got to try the problem before you request to go over it. So this was about a 37 minute long video, about right for a 90-minute class period. And you should know how to reach me if you have questions about the video or your assignment.